Let's talk about zeros and their multiplicities, because the multiplicity of a zero will tell us the behavior of the graph near that zero. So if I'm looking for zeros, I want to first take my polynomial, set it equal to 0, and then either x minus 3 squared equals 0 or x plus 5 is equal to 0. Square root of both sides over here gets me to x minus 3 is equal to 0, which in the end gives me x equals 3. And over here, I get x is equal to negative 5. The difference between these two zeros is the number of factors that that zero comes from. So for example, x equals 3 is a 0. It comes from the factor x minus 3. So this is the factor. And there are 2 of those factors. And the reason for that is because I have this squared exponent right here in the function. So what we say is a 0 of this polynomial is x is equal to 3, and it has multiplicity 2 because there are 2 factors of x minus 3, versus our other 0, which is x is equal to negative 5, but it comes from the factor of x plus 5, and there's only one of those factors. You can see there's only one factor of x plus 5, so it has multiplicity 1. So the multiplicity of zeros just comes from how many factors that 0 comes from that you see. Depending on whether the multiplicity is even or odd will tell you how it behaves. So 2 is even versus 1 is odd. If you have a 0 with odd multiplicity, you are going to cross the x-axis at that 0. If you have an even multiplicity, you are going to touch the x-axis and turn around. Okay, so if I think about, let's think about what the graph of this x minus 3 quantity squared times x plus 5 looks like roughly. Okay, so we know that we have a 0 at 3, so here's 3 comma 0. And we know we have a 0 at negative 5 comma 0. The other thing I might be interested in is where it crosses the y-axis. That's at f of 0. If I plug that in, I get negative 3 squared times 5, which gives me 9 times 5. That's 45. Pretty big. My scale was not going to accommodate that, so we'll go with the fact that I labeled the point. Is going to help me out with that. Okay, the leading term, if you factored everything out, you'd end up with an x squared from the x minus 3 quantity squared, and you would have an x from the other factor, so x cubed is the leading term. Again, I'm just trying to get my hands on the leading term, so I'm just grabbing the biggest things from each of them. We know the end behavior for that is going to be a down-up, so I should be down here, and then I should be up here when I'm done. Okay, so let's add these thoughts together. So I should be down here, and I'm going to hit here, and since negative 5 is a 0 of multiplicity 1, I'm going to cross the x-axis. So whoop, there I go. Somewhere in here, I'm probably going to turn around. I'm not sure if it's above or below that. Maybe it's right at that. My guess is it's above. But either way, I'm just getting a rough idea. And I'm coming back down. And I know I got to go through the point 3 comma 0. 3 comma 0 is a multiplicity 2. That's even. So instead of crossing there, what I'm going to do is I'm going to touch it and turn around, which also lines up with my end behavior sort of thought. So that's how the multiplicity of zeros allows us to figure out what a function looks like from essentially the formula aspect of it. So if we try another one, let's go with, how about g of x is equal to 4 times x minus, let's see, how about, I like 4s today apparently, 4 cubed times x plus 2. If we look for the zeros of those, it looks like I have 2 options. Either x minus 4 cubed is 0, or x plus 2 is 0. Technically, you could set 4 equal to 0, but I'm not going to get any solutions out of that. So this 4 just doesn't give rise to any zeros, and that's fine. So if I focus on the ones that are going to give me something I want, take a cube root of both sides, you end up at x minus 4 is equal to 0, which gives me x is equal to 4. So that's a 0. And it has multiplicity 3 because I have 3 factors of x minus 4. 3 is odd, so that means I'm going to cross the x-axis. The other one, I get x is equal to negative 2, so x is equal to negative 2 is another 0, and it's a multiplicity 1 because I have only one factor of x plus 2. 1 is also odd, so I'm going to cross the x-axis there as well. The only difference between how I cross these is for multiplicity 1, I'm going to cross like a linear, as in I'm going to cross like a y is equal to x. And this multiplicity 3 one I'm going to cross, but I'm going to cross it like y is equal to x cubed. It's a subtle thing to incorporate that into your graph, but it is how it behaves, so it's nice to be accurate that way. So, okay, here's our graph. So at 4, 0, and negative 2, 0, some things will be happening. Also, I want to get a hand on the leading term so that I can get an idea of my end behavior. I got a 4 from the first part. I'll pick up an x cubed from the x minus 4 cubed if I FOILed it all out. I just don't want to spend the time to FOIL it all out. So I'm just grabbing the biggest x values, and then from the x plus 2 factor, I'm going to get an x. Overall, this is a 4x to the 4th. The 4 up in the exponent is even, and the 4 up front is positive, so I'm going to have end behavior of an up. So I should be up over here, and I should be up over here when all is said and done. Okay, the other thing is I'm kind of curious on whether or not my y-intercept is going to be positive or negative. And so if I look at g of 0, this is 4 times negative 4 cubed times a 2. Now, that's a big number. I don't know what it is, but I do know it's going to be negative because a negative 4 cubed is negative times a positive 4 times a positive 2 is still a negative number. So I should cross down here somewhere is the important part. Okay, so start up here with my end behavior, coming until x is equal to negative 2. Negative 2 is a 0, so I should hit that point. And it's a multiplicity 1, which is odd, so I'm going to cross, and I'm going to cross like a linear function, kind of like a line. Okay? And then somewhere down here, I got to turn around. I don't know exactly where it is, but I'm just trying to get a rough idea of what this sketch is. I do know I should have a negative intercept, so it's down there somewhere. And then 4, 0 is also a 0, so I should go through that point. It's multiplicity 3, it's odd, so I'm going to cross, though, like x cubed. So a little bit of a whoop-de-whoop in there, but I'm still crossing it. And then my end behavior is still up. So it looks roughly like the following. So that's how zeros and their multiplicity help us determine what a graph is doing.